Okay, so I wanted to just do a quick little video on number 33 and 34. I'm not sure if you were assigned either of those, but I thought they were really good ones to talk about. Ooh, let's grab a whiteboard. So, and the first one, 33, was what is the result of applying the law of cosines when the given angle measure is 90 degrees? So let's go ahead and draw. Can we see what I'm doing? Okay, there we go. So let's say we have A, B, and C. So that means this is little a, little b, little c, and this is a 90-degree angle. So if I'm doing law of cosines, and I know that this angle is 90 degrees, I'm going to use this angle. So we have that c squared equals a squared plus b squared minus 2ab cosine of c. Well, the one thing I know here is that the cosine of c, this is actually going to become the cosine of 90 degrees. And what is the cosine of 90 degrees? I happen to know that the cosine of 90 degrees is 0. If you do not know that offhand, and I won't get into a big explanation why, we would just take our calculator and say cosine 90 degrees, and our calculator says, oh, it's 0. So what's that mean for this whole term here? This whole piece here becomes 0. So then we have c squared equals a squared plus b squared plus 0, so there's nothing there. So basically we have this. And we might be more familiar with that as a squared plus b squared equals c squared, but that is the Pythagorean theorem. So the law of cosines, when we're dealing with a 90-degree angle on a right triangle, becomes the Pythagorean theorem. Okay, flipping this over, let's do, I have an erasing device somewhere. Ah, got it. Let's just keep it on here. Oh, I could have left my triangle. That's okay. We'll draw it again. That's a right angle, really it is. A, B, C, B, A, C. So now let's use the law of sines. And I know angle C, so I have to use sine of C over C. But I can pick whichever one for the other one. So let's go with sine of A over A. Now, I'm going to, let's say we're going to multiply, how do I explain this? Well, let's go ahead and solve this. What is sine of C? I happen to know that sine of C, in this case, it's going to become sine of 90 degrees. I happen to know that sine of 90 degrees is 1. And if you didn't know that off the top of your head, that's okay. Sine of 90 degrees is 1. So that means that 1 over C equals sine of A over A. Let's go ahead and move this guy over. So times A times A. I get that A over C equals sine of A. Or we're used to seeing that more as like sine of A equals A over C. But looking back at this triangle, and this is a right triangle, A is my opposite side, C is my hypotenuse. So sine of A equals opposite over hypotenuse. That's just our definition of the ratio of what the sine of A is, right? So if we were doing, we knew that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. You guys might have learned that as SOHCAHTOA, so you might have learned this as an O over H. However, or just sine, like however you learn it, there's a few different ways that they give you to remember it. But law of sines just turns into the definition of what a sine is when we have a right triangle. Okay, I think those were both fun. Oh, can we see the whole sheet? There we go. Yay!